In this example, we have to examine for functional dependence of the following functions. U is equal to y plus z, v equal to x plus 2z square, and w equal to x minus 4yz minus 2y square. Let us try to solve this question. We have to examine for functional dependence of the following functions. U is equal to y plus z, v is equal to x plus 2z square, and w is equal to x minus 4yz minus 2y square. So here u, v, w are dependent functions, and x, y, z are independent. Now, how to identify that the given functions are functionally dependent or not? So let us take the definition. We know that the functions u, v, w are said to be functionally dependent with respect to the variables x, y, z if Jacobian of u, v, w with respect to x, y, z is equal to 0. So now if you want to prove that Jacobian of u, v, w with respect to x, y, z is 0, then we can say that these u, v, w functions are functionally dependent. Let us consider left hand side. What is the left hand side? Left hand side is nothing but the Jacobian of u, v, w with respect to x, y, z. We have to prove that its value is 0. Now, what is Jacobian of u, v, w with respect to x, y, z? It is nothing but the determinant of del u del x, del u del y, del u del z, del v del x, del v del y, del v del z, del w del x, del w del y, del w del z. Now we have u equal to y plus z, v equal to x plus 2z square, w equal to x minus 4yz minus 2y square. Let us try to calculate what is del u del x. U is free from x, so its value is 0. Del u del y is 1. Del u del z is again 1. So this is the three values of del u del x, del u del y, del u del z. Let us come to v. Del v del x is 1. Del v del y is 0. Del v del z is derivative of 2z square is 4z. Similarly, what is the partial derivative of z with respect to x is 1. With respect to y, so this is both are functions of y. So minus 4z minus 4y, minus 4z minus 4y, and del w del z is only this term minus 4y. So these are the different values of the partial derivatives. Let us substitute all this in the determinant. So first one is the 0, 1, 1. This is the first row, 0, 1, 1. The second row is 1, 0, 4z, 1, 0, 4z. And the third row is 1, minus 4z minus 4y minus 4y. Let us try to simplify this determinant. So let us try how to solve this. So 0, this is 0. Let us leave this row and this column. 0 into minus 4y minus 4z or minus 4z minus 4y into 4z. First part is over. Second part, minus 1, this is minus 1. Leave this column and this row. So 1 into minus 4y minus 1 into 4z. Okay, now the third one, we have to use, this is plus 1. Leave this row and this column. 1 into minus 4z minus 4y minus 1 into 0 is 0. Let us simplify it. This total term will become 0 because it is multiplied by 0. So the first part is 0. Second part, this minus 4y minus 4z, and again we have the minus sign. So let us write minus 4y minus 4z. Now here minus 4z minus 4y, and it is 0. So if we simplify it, it is 0. This minus and minus will become plus, and it will also become plus. So 4y plus 4z, and it is minus 4z minus 4y. So the plus 4y minus 4y plus 4z minus 4z. So the ultimately the answer is 0, which is right hand side. And this proves that since Jacobian of UBW with respect to XYZ are zero, it proves that the given functions are functionally dependent. Thank you.